Hi there, my name is Minskar Labedis, and in this video, we will see one of the ways we can actually use our own calculator in the upcoming AP pre-calculus exams. As you know, or as you should know by now, in the AP pre-calculus, we will be assessed in 4 different parts. In 2 of them, we are allowed to use our own calculator. And by calculator, I mean something like that, the Casio FX6050 we have in front of our screens. Now, in section 2, part A is the part where the free response questions start. And more precisely on that part, on part A, we will be assessed on 2 different questions. One of them will always be on function concepts. In this video, we will see one of the ways we can use our calculator in this direction. And I'm gonna title this way by finding zeros. This video, you should know that this video is focused on using the Casio FX CG50 calculator simply because in my own school, we work with that particular one. So how can we find zeros using our calculator? First of all, we need to have the function, okay? Assuming that the function will be provided by the AP itself, we have 2 ways. First way is through the solve and command. Remember that a zero by default is a value of x for which f of x equals 0. So, assuming that we were being provided with the function, and assuming that the function was, let's say, f of x equals 5 over x minus 2, in order to find the zeros, I need to solve this. F of x equals 0, so 5 over x minus 2 equals 0. Although this is an easy task, even by hand, remember that this video is about using the calculator. So remember that we have to do option, calc, and then solvent. Now, where can we actually find these commands, option, calc, and solvent? We should go to the menu, look at that here, of our GDC menu, and click on the run matrix, which is placed on the top left corner to help us out, and simply because I want to create a PDF from this as well, I'm gonna take them here and I will paste it here. The run matrix is that. Click on that with Excel. Next, we want to use the option button, OPTN. There is literally a button titled OPTN on your calculator. Once you click the OPTN button, and let me put that here as well. Once you click on that, which is this thing will pop up in your screens. Now we need to click on the calc. Remember, the order goes option, calc, solvent. So now we need to apply the calc. In order to apply calc, we just need to click on F4. So F4, and then we need to click on the solvent, which can be clicked by pressing the F5. So there it is, the solvent. Remember, it's always about option, calc, and solvent. What this series of commands did to our GDC is that it created that solvent prompt over here. And in this prompt, we are able to put our given equation. For our own example, that was equal to, let me reduce that one so that I can put fraction 5 over x minus 2 equals, with shift and dot, equals 0. Remember, we are looking for the zeros. X, this warning message will always be there. Press exit and ignore it. And there you are, no solution. So for this one, if we just clicked on solvent 5 over x minus 2 is 0, it would have provided no solution. And that makes sense because a fraction is only equal to 0 when its numerator equals 0, and this will never happen in this case. Let's work now more such exercises. Let's assume that we need to find the zeros of gx equals x squared plus 5x. Again, we will go and use the solvent button, and inside the solvent, this time we should put x squared plus 5x equals 0. So x squared plus 5x equals 0. Remember, ignore this warning, and we end up with -5 and 0. It's not one decimal point, it's two different solutions, -5 and 0. Another example, h of x is 2 times ln of x minus 1 plus 7. So once again, we should go in the solvent command and simply input this info. Plus 7 equals 0. So solvent 2 times ln bracket x minus 1, close the bracket, plus 7 equals, with shift and dot, 0, exit. So we end up with 1 comma, this is a decimal point, 0.30197383. Remember that both in AP pre-calculus as in calculus also, we need to either input all the entire number or the first 3 decimals. Let's move on another one. K of x is equal to 0.25 x cubed minus 9.5 x squared plus 110x minus 200. No problem at all. All we have to do is create the solvent command with following the series option calc solvent, and now be careful because we don't have enough evidence to reject or to verify our solution. So we should be extremely careful on putting the exact expression. Equals 0, x exit. So the solution to that is 2.218. Remember, the GDC can solve any possible equation. If the GDC cannot, or if there aren't any solutions, then it will state it, as it did in the beginning. It will state no solutions. Now, that was the first way, which can be done through the solvent command. There is, however, a second way, which is through graphing. Through graphing. Let's see. To enable that, we need to go to menu and then graph. Let me also extract this for the PDF, which can be found below this video. Let's put, so this time we will be doing the graph. Excel, and there you are. Up here in the Y1, we should put our given function. For us, let's use the same one. It's 5 over, so 5 over x minus 2. So let's take it over there. Let's put it here. And we are ready by clicking Excel to draw that. Now, the thing with drawing, with using the graph, is that sometimes we might need to zoom in or zoom out to simply see the graph. Here, for instance, we can do that by plus or minus. We can zoom out by the negative. Okay, and you have here the graph. This indeed will be the graph of f of x. And as we will see in other similar videos that will follow on applying the GDC in our own exams, this might be a handy approach, especially in exercises where we need to calculate the end behavior of the graph, or the monotonicity of the graph, or the concavity of the graph. If we have the graph in front of us, everything is easy. In here, remember that this video is about zeros. How can we calculate zeros? There is this gsolve. Most of the game in graphing is played with this gsolve command, which can be brought by F5. So F5, this will create this command list below. Let me put that here. The command list goes as follows: root, max, min, y-intercept, intersect, which stands for intersection. Remember that we need the zeros. So in order to get the zeros, we will need to click on root. Zeros is also equal to roots. So I'm clicking on that, F1, not found. This means that this graph does not have any x-intercepts, any roots, any zeros. Let's work with some more. For instance, and let's follow the same examples as before, let's assume that we have g of x is x squared plus 5x. Again, I should return back here, and let's delete that with del and F1. So now I'm going to create x squared plus 5x, xa, which will draw that graph, gsolve, and root. You see that the cross highlights the first root, but I can see that there is another one. How can I reach that other one? By moving the cross to the right. So there they are, -5 and 0. Let's draw another one. Before we had h of x equals to ln x minus 1 plus 7. So let me plug this expression here, x minus 1 plus 7, xa, draw, it's this one. Did we find any solutions before? We did. It was 1.gsolve root. It found it, 1.03. The tricky part here is that we should, let's say, trust it, but remember that it can be tricky sometimes, because by just looking at that, it seems as it was cut. However, it does have roots. The only reason is that at this point, probably the graph itself presents an asymptote, and the GDC could not easily show that. You see that as I zoom in, there's obviously an x-intercept, but if I zoom out, it seems as it is flying and it doesn't have any. So always be careful, but always, in the very, very end, trust it, because you see that if you click on Gsolve and root, it will actually produce the result. Sometimes, however, it can be tricky when we do not see the graph. For instance, let me draw this 0.25 x, not squared, x to the power of 3 minus 9.5 x to the power of 2 plus 110 x minus 200, and I drew that. But this looks like a line. If I zoom out, you see that it's lost. And it seems that there is such a curve. Okay, things are getting out of hand. But anyways, I just needed to find the x-intercept. So Gsolve root, and it does calculate that. To be sure, I move the cursor to the left and to the right so that I can check if it can identify any extra zeros. It doesn't, so this is my only option. Remember that by applying the calculator, there are two ways to find a function's zeros. First of all, directly in the run matrix, where we just create the command solven by following the series option calc solven, we input the given equation, and there you are. We get the results. Or second way, through the functions graph, in where we input the graph's equation. Once this is drawn, we click on the Gsolve, which is F5, and then roots. That's all. I hope things are way easier now. In case you do still have any issues, please let me know by putting a comment below this video. As always, thank you for your time.